Question number 25th. A factory manufactures two types of screws A and B, each type requiring the use of two machines, a automatic and a hand operated. It takes 4 minutes on the automatic and 6 minutes on the hand operated machine to manufacture a packet of screws B. Each machine is available for at most 4 hours on any day. The manufacturer can sell a packet of screws A at a profit of 70 paisa and screws B at a profit of 1 rupees. Assuming that he can sell all the screws he manufactures, how many packets of each type should the factory owner produce in a day in order to maximize his profit? Formulate the above LPP and solve it graphically and find the maximum profit. Let the factory manufactures X screws of type A and Y screws of type B on each day. Hence, X is greater than equal to 0 and Y is greater than equal to 0. Given that, if we put the values given in the question in a tabular form, we'll get automatic machines produce 4 screw A's, 6 screw B's, and hand operated machine produces 6 screw A and 3 screw B. Profit for both screw A and screw B are 70 paisa and 1 rupee. Here is the availability of the machines. The constraints hence formed are 4x plus 6y, that is smaller than equal to 240, 6x plus 3y, that is smaller than equal to 240. Total profit is equal to 0.70x plus 1y. LPP is maximize 7 is equal to 0.7x plus y, subject to 2x plus 3y smaller than 120, 2x plus y smaller than 80, x greater than equal to 0 and y greater than equal to 0 was given. Now plotting the points on the graph, we'll get the common feasible region, that is OCBAO. Now the correct points for the points A, B, C, O. For A, 40, 0, 7A is equal to ZA is equal to 28. For point B, ZB is equal to 41, that is maximum. For point C, ZC is equal to 40, and for point O, ZO is equal to 0. Hence the maximum value of Z is 41 at point 32. Thus 30 and 20. Thus the factory should produce 30 packages at screw A and 20 packages of screw B to get the maximum profit of rupees 41.